Okay? So we talked about the vertex. And then again, I told you another key feature kind of correlates with the vertex, right? Because it kind of goes through the center of it, or it goes through that vertex point. Anybody remember what we called that? That was not a good explanation. But let's say I have this parabola right here, and you have this dashed line going down through your vertex. The axis of symmetry, right? Okay, so let's talk about your axis of symmetry. Again, what does it mean for something to be symmetrical? What does it mean if something's symmetrical, right? Yesterday I came up here and I drew a square, okay, and I showed you, hey, it's symmetrical. Vertically, it's symmetrical. Horizontally, what does that mean? It's the same, right? So the left side mirrors the right side, or the top mirrors the bottom, right? If I was to fold it along that axis of symmetry, okay, they would overlap. If I was to take this parabola and fold it along this axis of symmetry, which in this case is your y-axis, okay, this line would be directly on top of that line. Okay, sure. You'll get out your journal. Okay, so let's write a definition for axis of symmetry, just to review it real quick. Okay, your axis of symmetry is a line. Okay, and again, with a parabola, it's going to be an undefined slope, which just means it's a vertical line. So it's a line with that W slash, that W and that backslash is abbreviation for width, within undefined slope, just meaning it's a vertical line. And it's going to go through, so that goes through your vertex. So your axis of symmetry, you'll usually see it as a dashed line, or if you're asked to draw the axis of symmetry, you'll draw it as a dashed line. And again, it has an undefined slope, meaning it's a dashed vertical line that goes through your vertex. Because again, your vertex is your lowest point or your highest point that's at the center of your parabola. Okay, so it's going to go, your axis of symmetry is going to run through that vertex. And that's why I told y'all yesterday, right? When you write your equation for your axis of symmetry, it's going to be x is equal to, and then whatever value that x coordinate is for your vertex. Okay, and we'll look at some examples of that in a minute. Right, so if your axis of symmetry is your y-axis, okay, well we haven't gone left or right any from the origin. Right, so my x coordinate on the y-axis is 0. So that would be x is equal to 0. Right, in this case right here. Or that one's been shifted, but in that case, it would be x equals 0. Okay, so we talked a little bit about that. Then we talked about our domain and range. Okay, so let's take or write a definition for domain. Anybody remember from yesterday what my definition of domain is? Deshaun, you think you know? The input. Okay, so we talked about it. It's the set of all possible input values. The set of all possible input values. And then I showed you what that meant yesterday, okay, by giving you an equation in the table, right? So our input values, we were like, well, what does that exactly mean? So I came over here and I gave you all an equation. Let's say it was, let's use a quadratic, y equals x squared, right? So this is my parent function for a quadratic. So we're talking about what does it mean for something to be the input. And then I gave you this table, okay, with our x and y coordinates, our ordered pairs, and I said, well, finish the table. Well, how can we finish the table and give it an equation and then my x coordinates? How can I find those y values? What did we talk about yesterday? What can I do with these numbers right here? What can I do with them? How can I get my y values? What am I doing? I have this equation, y is equal to x squared. Okay, and then I have a table of values with my x's. Okay, how can I find my y's? Plug them in, right? We're going to input these x's into our equation. Right? If y is equal to my x value squared, then this y is equal to 0 squared. Right? So y would be equal to 0 squared. Well, 0 times 0 is 0. So how can I find what y is when x is 1? take the 1 and put it in for x, right? So y is equal to 1 squared. Well, 1 times 1 is 1. Okay, same thing for 2. Y is equal to, I put this 2 in for x, 2 squared. 2 times 2 is 4. So what did I do every time? I took these x values and I inputted them in for x. That is why our domain is talking about our x values, our input values. So when you see domain, again, I want you to think my possible x values. Okay, domain correlates with my x. We're talking about our set of all possible x values. Okay, input and x, these are interchangeable right here. Okay, talking about all my possible x values. And then again, if domain is talking about your x values, what is your range talking about? My output, right, which is my y values. Okay, so range is talking about your y's. So it's our set of all possible y values, or output values. Okay, and we're about to do some practice problems with domain and range. I just wanted to go back over the definition. Again, I think I told you yesterday, I think that these would be good test questions if I said, hey, give me the definition of domain. Give me the definition of range. So that's a possibility. Okay, so I'd highly advise you memorize or at least correlate domain is my x's, range is my y's, because you're going to have to know that. Okay? Alright, so let's talk about what this looks like on a graph. Okay, you do not have to draw this graph, but in your journal, okay, we are going to talk about the vertex, the domain, range, axis of symmetry, vertex, and the max or min. Okay, so we're looking at this D1. Okay, this is going to be example 1. So go to your next page in your journal. You can write example 1. Okay, so we're going to find these 5 attributes of this graph together. And then in a minute, I'm going to pass out your assignment, and you're going to do it yourself. Okay, so make sure you're taking good notes. So this would be in your journal, example 1. Okay, we're going to start with finding our vertex. Let's start with that. Okay, so looking at this graph, okay, again, we're talking about this one right here on the top left. We're going to start by finding our vertex. Okay? Again, my vertex is either my highest or lowest point, depending on the shape of my graph, right? If it's opened upwards, okay, like this one is, I'll have a lowest point, which we call the what? Minimum. Okay, and then if it's been reflected over the x-axis, okay, and I have that upside down U shape, I have the highest point, which we call what? The maximum. Okay, so is this one going to have a minimum or maximum? A minimum, right? We're going to have the lowest point on the graph somewhere on this parabola. Okay, well, where is that vertex going to be in this problem? And again, it's kind of hard to see your numbers. Okay, so, alright, so I have an ordered pair when x is -3. Okay, so again, when we're talking about a vertex, we're going to write it as an ordered pair. But it's not just -3. Okay, because I've got to give that y coordinate. What is my y coordinate here at the vertex? 0. So I would write that as -3, 0. So my vertex is -3, 0. And again, since we found our vertex, now we can find our axis of symmetry, right? Because we know that that axis of symmetry is going to be the undefined line that goes through that vertex. Okay, so let's find our axis of symmetry. And again, that's going to be an equation that x is equal to something. Since it's an undefined line, since it's a line with an undefined slope, it's vertical straight line. Okay, it's going to be x is equal to something. Okay, now again, I told you that your axis of symmetry will always be x is equal to that x coordinate of your vertex. Well, what's the x coordinate of my vertex? -3, right? So x is equal to -3. So we're thinking, well, what does that axis of symmetry look like? Okay, so if I go back to my graph, here's x at -3, right? Notice my vertex is on that coordinate right there. If I draw a vertical dashed line right here, that would be my axis of symmetry. So on that line, if I folded my parabola in half on that line, right, this side of my parabola would be directly on top of this side with no hangover, because this side is equal to this side, right? If we were to pick a point, okay, from my axis of symmetry, let's say this point, there's 3 squares from this point to this line. Well, same thing on this side. There's 3 squares on the left. Okay, so it is equal on both sides. So it is symmetrical. Alright? So we found our vertex, we found our axis of symmetry. Okay? Now let's label, and I should have done this after vertex. Is it a max or min? Min, right? We already talked about it. Let's write it down. Say minimum. Because again, it's the lowest point. My graph opens up. Okay? And all that's left to find, and all I'm asking you to find now is your domain and range. So this is just like what you're going to do in your assignment in a minute. Okay? You're going to find your vertex. Okay? The max or min. Find the axis of symmetry. Then we're going to write the domain and range. And again, there's multiple ways to write domain and range. We are going to use inequalities for now. We'll eventually get to intervals. Okay? Then I want to find the domain. Again, okay, looking at this parabola, the domain should be pretty easy on these. Why? Because we have arrows at the end of this parabola. Okay, so I'm just asking you, what is all my possible input values? Well, again, input is my x values. So if I'm looking at all my possible x values, so this graph is going up and out forever. Okay, it's expanding forever, up and outward, right? So that means I'm going to end up, okay, just going on. I could get to negative a million over here. Okay, so I could have an x-coordinate negative a million. I could have an x-coordinate positive a million. Okay, because it's going to keep going up and out forever. So what would my domain be of this parabola? I think I heard it. All real numbers, right? So you can either write that with this script R, or you could just write all real numbers. Okay, so again, if you have those arrows and it's going on forever, your domain is going to be all real numbers. Just like when we did our domain of lines, right, of a linear function. Okay, it's going to keep expanding forever and ever and ever. So our domain was all real numbers. Now let's talk about our range. Right? Our set of all possible output values. Okay, so looking at this graph, okay, this one is not going to be all real numbers, right? Why is it not going to be all real numbers? Right, we're talking about our y values, okay? And this graph is going up and out forever. What about down here? What about below my minimum? Could I have an ordered pair below this minimum? No, why not? Because that's my minimum, right? That's going to be the lowest point on my parabola. So no matter what x value I input into this quadratic equation, okay, that makes up this parabola, I'm not going to get an ordered pair below my minimum. So what is that saying? Well, our range is talking about our y values. What's my lowest y value on this graph? 0. Right? I'm on the x-axis. Okay, so my lowest y value is 0. And if this graph is going up and out forever, that means, okay, I can have any y value greater than or equal to 0. So above that 0 or equal to 0. So we would write that as y is greater than or equal to 0. Again, make sure on your range, we are talking about the y values. Okay, I heard someone say -3. Okay, you just mixed up your x and y. Again, with your range, we're talking about the y value. So take your max or min, find that vertex, okay, and see, is my graph going up from that vertex or is it going down from that vertex? Okay, then you can create your inequality based off that. Okay, let's do one more together as a class. I'm going to have you all work on this one by yourself. So we are going to do number 2, where it says D2. We're doing this one. So you yourself, you are going to find the vertex. You're going to tell me if it's a max or min. You're going to find the axis of symmetry, and then the domain and range. I'm going to call on someone random to do each one. So on this one where it says D2, finding the vertex, the axis of symmetry, tell me if it's a max or min, and the domain and range. Okay, so take some time to do that real quick, and then we will set you loose on your assignment. Yes, sir. No, D2, this one right here. Y'all are doing this problem right here, D2. That'll be your example 2. So find the vertex. Tell me if it's a max or min. Find the axis of symmetry in the domain and range.